In this video I will show how to find the slope of the tangent line to the polar curve. To start, let's first recall that the slope of the tangent line is equal to dy dx. Now when y and x both can be written as functions of a third variable called parameter, then the slope or the derivative can be found by the following rule. So the question is only now, can we write the function, can we write x and y as a function of theta? And turns out that we can, just by using the fact that y is r sine theta and x is r cosine theta, and the last fact is that r is given by this formula. So instead of r, I can just write 4 plus sine theta. And now using this rule, we can find the slope of the tangent line. So I'm going to find this derivative separately. So let's differentiate the numerator here. So I'm going to distribute sine theta. So derivative of this is equal to 4 cosine theta plus 2 sine theta cosine theta, which is just sine of 2 theta. And derivative of the denominator, after I distribute the cosine over and apply a trig identity for a double angle, I'll get the following derivative: negative 4 sine theta plus cosine of 2 theta. So this is what we get as a derivative. So I write 4 cosine theta plus sine 2 theta over negative 4 sine theta plus cosine of 2 theta. We found the derivative as a function of theta, so now we just have to evaluate it at theta equals 3 pi over 2. So dy dx evaluated at theta 3 pi over 2 is equal to 4 cosine of 3 pi over 2 plus sine of 2 times 3 pi over 2 divided by negative 4 sine of 3 pi over 2 plus cosine of 2 times 3 pi over 2. Cosine of 3 pi over 2 is 0, sine of 3 pi is 0, and sine of 3 pi over 2 is negative 1, and cosine of 3 pi is also negative 1. So the answer is 0. So the slope of the tangent line to this polar curve at 3 pi over 2 is 0.